Ever wondered what it would be like if we could travel to space in an elevator? Imagine stepping into a cabin, pressing a button, and ascending into the cosmos. It's a fascinating concept, isn't it? Let's take a moment to explore this idea. A space elevator, a concept that was once confined to the pages of science fiction, is now becoming a topic of serious scientific discussion. The idea is both simple and revolutionary. It proposes a direct mechanical link between Earth and space, eliminating the need for rocket launches. Imagine a towering structure stretching from the Earth's surface to an orbital station in space. This structure would essentially be an incredibly long cable, anchored to the Earth at one end and attached to a counterweight in space at the other. The counterweight, constantly pulling away from Earth due to the centrifugal force of Earth's rotation, would keep the cable taut and straight. The cable, made from a material strong enough to withstand the gravitational and atmospheric forces it would encounter, would serve as a track for elevator cabins. These cabins, powered by solar energy and equipped with magnetic levitation technology, would glide effortlessly up and down the cable, ferrying passengers and cargo to and from space. The distances involved are staggering. The cable would need to be approximately 96,000 kilometers long, over 200 times the diameter of the Earth. The terminal on Earth, a floating port with a diameter of 400 meters, would serve as the departure and arrival point for the elevator cabins. Sounds like science fiction, doesn't it? But remember, many of the technologies we take for granted today were once considered fantastical. The rise of nanotechnology, the development of materials like carbon nanotubes, and the relentless march of scientific progress are bringing the concept of the space elevator ever closer to reality. This might sound like a futuristic dream, but with the rapid advancements in technology, the construction of a space elevator could be closer than we think. And scene script, Japan's Obayashi Corporation, known for constructing Tokyo's tallest building, recently completed a 2-year feasibility study on the space elevator concept. Let's delve into the intriguing details of this study. The Obayashi Corporation took on the challenge of investigating the technical and economic aspects of building a space elevator. Their findings? A mix of challenges and exciting possibilities. First, the technical challenges. The study recognized that the construction of a space elevator would require a cable made from carbon nanotubes stretching an astounding 96,000 kilometers. This cable, no thicker than a pencil lead, would need to withstand the colossal forces of Earth's gravity and extreme space conditions. On top of that, it would need a floating port on Earth, a staggering 400 meters in diameter. Now let's talk economics. The sheer scale of the project would require a significant investment. Yet, the Obayashi Corporation believes that the cost of space travel could be drastically reduced once the space elevator is operational. The financial benefits could be astronomical, pun intended. Despite these challenges, the Obayashi Corporation remains undeterred. They predict that by 2030, we will have the ability to produce nanofilaments of unlimited length. These nanofilaments could be the key to constructing the space elevator, making what seems like a science fiction dream a potential reality. The Obayashi Corporation's confidence in the feasibility of a space elevator is palpable. They believe that with the right technological advancements and adequate funding, the construction of a space elevator could be completed by 2050. If successful, this would be a game changer for space travel, potentially making it more accessible and affordable than ever before. The study concluded that a space elevator is not only technically feasible, but could also revolutionize space travel. Imagine the possibilities of a world where a trip to space is as simple as stepping into an elevator. The future might be closer than we think. The key to building a space elevator lies in a material that might surprise you: nanofilaments. Now, what are nanofilaments? Picture a strand of hair. Now imagine that strand being 100,000 times thinner. That's about the width of a nanofilament. These tiny structures, often made from carbon, are not just impressively small, they're also incredibly strong. In fact, when it comes to strength-to-weight ratio, carbon nanofilaments outperform almost every known material. So why are these tiny, super-strong structures so crucial in the construction of a space elevator? Let's take a moment to think about the challenges of such a project. The elevator would need to stretch from Earth to space, a staggering 96,000 kilometers. That's about a quarter of the way to the moon. The cable that makes this journey possible needs to be strong enough to withstand the immense stresses of this journey, light enough to be feasibly lifted into space, and long enough to reach our final destination. That's a tall order, And that's where our nanofilaments come in. Their unique combination of strength, lightness, and potential for unlimited length makes them the ideal candidate for this ambitious task. Imagine a cable made from billions upon billions of these nanofilaments, stretching from the surface of the Earth to the stars. It sounds like something out of a science fiction novel, doesn't it? But with the advancements in nanotechnology, it's becoming less fiction and more science. Predictions indicate that by the year 2030, we'll have the capability to produce nanofilaments of unlimited length. This means that the key material for our space elevator could be ready in less than a decade. So, while the concept of a space elevator might still feel like a distant dream, it's important to remember that every journey starts with a single step, or in this case, a single nanofilament. With the anticipated production of unlimited length nanofilaments, the dream of a space elevator is inching closer to reality. So, when can we expect to see a space elevator in action? Well, according to the Obayashi Corporation, we might be only a few decades away from this incredible feat of engineering. After a comprehensive 2-year feasibility study, they've proposed a timeline that sees the construction of a space elevator by the year 2050. That's right, within our lifetimes we could witness the dawn of a new era in space exploration and travel. But what does this mean for us? The potential impacts of a space elevator are immense. For starters, it could revolutionize space travel by providing a more cost-effective and accessible means of reaching outer space. Currently, launching a satellite or sending astronauts into space is an expensive venture, largely due to the rocket fuel costs. But a space elevator, once constructed, would dramatically reduce these costs, making space more accessible to a wider range of industries and countries. That's not all. The space elevator could also pave the way for more ambitious space endeavors. Imagine being able to transport materials and personnel to space easily and regularly. This could facilitate the construction of space stations, the mining of asteroids for resources, and even the colonization of other planets. The possibilities are as vast as the universe itself. Moreover, the space elevator could bring about a new era of space tourism. Instead of a select few astronauts, anyone could potentially take a trip to the stars. Picture this, stepping into an elevator and ascending into the cosmos, watching as Earth shrinks away beneath you. Such an experience could fundamentally change our relationship with space, making it a part of our daily lives rather than a distant, unreachable frontier. However, it's essential to remember that these are just predictions. The construction of a space elevator is a colossal task, requiring advancements in technology that are yet to be fully realized. But the progress we've made so far is promising, and it's exciting to think about what the future holds. As we look to the future, the possibility of stepping into an elevator and traveling to space is becoming more and more tangible. Let's take a moment to reflect on the incredible journey we've just discussed. We began with the concept of a space elevator, a seemingly fantastical idea that's been floating around the realms of science fiction for decades. Imagine a cable stretching from the Earth's surface all the way into the cosmos, carrying passengers and cargo into space without the need for rocket propulsion. Sounds like a dream, doesn't it? But this dream took a step closer to reality with the Obayashi Corporation, the masterminds behind Tokyo's tallest building. They dared to investigate the feasibility of this extraordinary concept. For 2 years, they pored over every detail, every challenge, every potential solution, and they concluded that yes, a space elevator could be more than just a dream. The key to this possibility? Nanofilaments. These minuscule strands of carbon are incredibly strong, yet unbelievably light. The Obayashi Corporation predicts that by the year 2030, we'll have the technology to produce nanofilaments of unlimited length. This breakthrough will pave the way to constructing the backbone of the space elevator, a cable made entirely of these carbon nanotubes. This cable, according to the Obayashi Corporation's vision, will stretch an astounding 96,000 kilometers into the cosmos. At its terrestrial end, a floating port 400 meters in diameter will serve as the departure and arrival point for the celestial elevator. And when can we expect to see this marvel of engineering? The ambitious target is the year 2050. A little over 2 decades from now, we could be standing at the threshold of a new era in space travel. The next few decades will certainly be exciting as we watch the dream of a space elevator unfold. Who knows, maybe one day we'll all have the chance to take an elevator ride into space.